Hi everybody and welcome to Standard 17. Standard 17 is about coordinate geometry. So let's take a look at Standard 17. It says here, Standard 17, students prove theorems by using coordinate geometry, including the midpoint of a line segment, the distance formula, and various forms of equations of lines and circles. So, the problems are going to be, here's Standard 17, 69 and 70, as well as 70, 71, 72, and 73. Okay, so 69 through 73. So let's look at problem 69. The diagram shows triangle ABC. Here's triangle ABC. Which statement would prove that triangle ABC is a right triangle? So this is actually what I consider maybe the hardest problem in the entire STAR packet. We're saying right triangle, so we're going to say that this has to be 90 degrees. So what we've got here is this side, and we need for them to be perpendicular. So if you remember, perpendicular slopes are negative reciprocals. So let's say that this one has a slope of x over y, and that this one has a slope negative reciprocal, so negative y over x. So that would mean that they were perpendicular because they are negative reciprocals of one another. So if that's true, then let's see what our answers are. A says the slope of AB times the slope of BC equals 1. So let's see, if we multiply these, we get negative yx over yx, which would reduce straight down to negative 1. So it's not 1, it's negative 1. So let's see if we have something that says that. B says the slope of AB times the slope of BC equals negative 1. Well, that looks like the right thing. A obviously doesn't work because when we multiplied it, we got negative 1, not 1. Okay, C, we get distance from A to B equals the distance from B to C. So that's basically saying that this is congruent to this. Well, that would make it isosceles, but not all isosceles triangles are right, so that can't be the answer. And D, distance from A to B equals negative the distance from B to C. So, well, is there really any such thing as negative distance? No. So you got to look at D and just say that's nonsense. That's not even a possible answer. So the one that makes sense is B. Again, the reason is the slopes have to be negative reciprocals. If you multiply negative reciprocals times each other, they reduce to negative 1. Therefore, the answer is slope of segment AB times the slope of segment BC equals negative 1. And that's number 69. Okay, figure number 70. Figure ABCO is a parallelogram. So this is a parallelogram. What are the coordinates of the point of intersection of the diagonals? So it's really saying what are the coordinates of this point? Well, what you should realize is that in a parallelogram, diagonals bisect each other. And because they bisect each other, this point is exactly halfway between here and here, as well as the halfway between here and here. So we just have to take the midpoint, or the averages of opposite coordinates. I'm going to choose to do the midpoint of AC, just because. So the x value for A is A, and the x value for C is C. So it's going to be A plus C divided by 2. That's going to be the x value for the center. The y value for A is B, and the y value for C is 0. So it's going to be B plus 0 divided by 2. That becomes A plus C over 2, comma, B over 2. So do we have anything that looks like that? Yep, I see it right here. It's in C. Again, what we did is we took the average of the opposite points. You can do the average of these or the average of these. You'll get the same answer either way, and that will be the midpoint. Okay, 71. What type of triangle is formed by the points A, 4, 2, B, 6, negative 1, and C, negative 1, 3? The best way to do this is to graph it. So let's make a little graph. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. As you can see, I'm being sort of careful to make sure that all the units are the same size. Sure, they're not perfect, but they're basically pretty close. So A is 4, 2. So that's 1, 2, 3, 4, 1, 2. So that will be A. B will be 6, negative 1. So this is 4, this is 6, and that's negative 1. So there you have B. And C will be negative 1, 3. So here's negative 1, 1, 2, 3. Okay, when we connect these, we're going to see that the triangle we get, okay, is clearly obtuse. It's not right. It's not equilateral. It's probably not isosceles because AC looks to be longer than AB. You can do the distance formula to prove it, but it's pretty clear that this is longer than this. So I'm going to say it's scalene and leave it at that. If you did the distance formula, you get that this is 1, 2, 3, 4, 5, and this is 1, so this would be the square root of 26 because it's 25 plus 1. And this is 1, 2, 3, this is 1, 2, so that's the square root of 13. So clearly different distances. This one is clearly longer than either of those. So we have 3 different side lengths, therefore it is scalene. Okay, 72. The point negative 3, 2 lies on a circle whose equation is x plus 3 squared plus y plus 1 squared equals r squared. Which of the following must be the radius of the circle? Alright, here's the thing. We know the center. The center is negative 3, 2. So, remember, the way this works... Oh, I'm sorry. The center is negative 3, negative 1. I'm sorry. And this point is on here. So, what we do is we can plug these numbers into the equation to find out the radius. It's the simplest way to do it. So what we're going to get is negative 3 plus 3 squared plus 2 plus 1 squared equals r squared. So negative 3 plus 3 is 0, and 0 squared is 0. Plus 2 plus 1 is 3, and 3 squared equals r squared. 0 squared is 0, 3 squared is 9, so 9 equals r squared. So we take the square root of both sides, and r equals 3. And that is that for number 71, or 72. Sorry about that again. And here we go, 73, last one. What is the length of the segment PQ shown below? Okay. So clearly what we've got is a diagonal segment. And the thing about diagonal segments is that you can't measure them on the grid directly. So what you have to do is create a right triangle. Basically, this is what's known as the distance formula. It's the Pythagorean theorem on a plane. So the x value here goes from 0 to 8, so it's going to be 8. And the y value goes from 1 to 7. So 1 to 7 is going to be 6. So we have a 6 and an 8. We're going to do the Pythagorean theorem, so it's going to be 6 squared plus 8 squared equals x squared. That's 36 plus 64 equals x squared. It's 100 equals x squared. Take the square root of both sides. X equals 10. No problem. Okay. Well, that's it for Standard 17. Thanks a lot. Rewind if you need to. Sorry about a couple of those mistakes, but pay close attention. I hope I corrected them correctly. And thanks. Good luck. See you next time.